Hello everybody, welcome to my next video. Today I'll be talking about modern periodic table and its properties. After a lot of defects in Mendeleev's periodic table, in 1963, Henry Moseley, he classified the elements in a new concept, in a new way. He classified about 118 elements in a law which is known as modern periodic table. Modern periodic law. According to modern periodic law, the physical and chemical properties, of the elements are the periodic function of their atomic number. Point to be noted, periodic function of their atomic number. Earlier in Mendeleev's periodic table, the elements they were classified on their atomic mass. And the drawback of Mendeleev's periodic table, there was position of hydrogen. It is now cleared with this new modern periodic law. After solid interval of atomic number, the physical and chemical properties of the elements get repeated, which is known as the periodic function, like I talked in my previous video. Okay. After classifying the elements in atomic number, the modern periodic table, long form of modern periodic table, consists of 7 periods, and 9 groups. Okay, I want to focus on it first. Many of them, they tell there are 18 groups, but there are not 18 groups. There are 18 columns. There are 18 columns. यस्तो खालको 18वटा कोलमहरु हुन्छ मोडर्न पिरियोडिक टेबलमा. तर हामी के भन्छौं, there are 18 groups भने. There are not 18 groups, there are 9 groups. Starting from group first to group 7 and group 8 and 0 group. It means 7 from here, 8, 9 groups are there. Among group first to group 7, it is subdivided into subgroup A and B. So total it will be 14. Group 8 will have 3 columns. 1, 2, 3. Here are also 3, 1, 2, 3. 3 columns, and 0 group has 1 column. Altogether there are 18 columns in which they are combined together to form 9 groups. The elements, they are classified as 7 periods and 9 groups. The 7 periods in modern periodic table. The first period consists of 2 elements. So it is called shortest period. Just 2 elements, first period. Second period and third period consist of 8 elements. They are called short periods. Fourth period and fifth period, they are called long period, having 18 elements together. Sixth period consists of 32 elements and it is the longest one. And seventh period, it is incomplete period because it consists of gaps there, so that newly discovered elements can be fulfilled here. So, 7th period is incomplete period. When we talk about modern periodic table, in modern periodic table, we need to know few things, few characteristics, few properties. Like earlier I told the number of periods and the number of groups. Now let's talk about little more about the position of elements, how the elements are classified in modern periodic table. The elements are classified in modern periodic table as metals, metalloids, non-metals. So in extreme left side, there are metals. first, second, third, fourth, fifth, sixth, seventh. Okay. First, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. I think almost it will come over here. Let's see. Okay. So this is the model periodic table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Okay. So the elements, they are arranged in this type of manner. Like the first position is of hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. In that way the elements, they are classified. The elements, they are grouped as metal. The elements consist of groups. I told you earlier, elements, they are classified in groups. This is first A, this is second A, this is third A, this is fourth A, this is fifth A, this is sixth A, this is seventh A, and this is zero group. I think one more I made over here. And this is zero group, and this is first B, second B, third B, fourth B, fifth B, sixth B, seventh B, 1, 2, 3, 8. Like this, the elements, they are classified as group. The elements of group first A, this group, they are called alkali metal. They are called alkali metals. The elements of first A group are called alkali metal because their oxides are soluble in water. For example, sodium, Na. Sodium oxide, Na2O. When we dissolve it with water, it forms sodium hydroxide, NaOH. It means the elements of group first A, they have the oxides soluble in water. Metallic oxides are soluble in water. So they are called alkali metal. The elements of group second A, they are called alkaline earth metal. They are called alkaline earth metal because their oxides are also soluble in water, and we can find them in mines, ores, in earth crust. So they are called alkaline earth metal. Got that? Okay. The elements of group 7th, this group, they are called halogen. They are called halogens. The elements of group 7, they are called halogen because they combine, they are non-metal. Okay, they are non-metal. When they combine with metal, they form their respective halides as metallic salt. You know, metallic salt or forms just the chlorine word. Sodium plus chlorine gives sodium chloride, NaCl. They form their metallic halides. Sodium halide, sodium chloride word. That is, it forms its metallic salt, so they are called halogen. The elements of zero group, they are called inert gas. They are called inert gas. Why they are called inert gas? Because they have zero reactivity. Why they have zero reactivity? Because their valence shell is filled with either 2 or 8 electrons, having the stable electronic configuration of duplet state or octet state. D-U-P-L-E-T, duplet. Octet state. Duplet state having 2 electrons in L cell, and octet state having 8 electrons in rest of other cells in outermost cell. What I mean to tell is K means 2 electron, L, M, N, O, like that. K, L, M, N. The cells are like this. K, L, M, N. K 2 electrons, and rest of others, they must have what? If they are valence cell, then they must have 8 electrons to be octet state of stable electronic configuration. Okay, the elements of group first and second A are called S block elements. S block, because their last electron is filled in s suborbital. The elements of group 3rd to 7th and 0 are called p block because their last electron is filled in p suborbital. The elements of second group, okay, subgroup B, they are called d block. In the same manner, their last electron is filled in d suborbital, and the elements of lanthanide and actinide series are called F block because their last electron is filled in F suborbital. Like this, the elements, they are classified in modern periodic table: S, P, D, and F block elements. Okay. Now let's talk about reactivity of the elements. Okay, let's talk about reactivity of the elements in modern periodic table. How reactive they are, how the reactivity goes on in modern periodic table. In periods, while going from left to bottom, the reactivity of the elements decreases and increases and finally become 0. First it decreases. First highly active metals are here. Then the reactivity decreases. And highly active non-metal comes where the reactivity increases again. And when inert gas comes, the reactivity finally becomes 0. This is how the reactivity goes in modern periodic table. Now in groups, you need to know certain things about group. Groups are the codons, and due to which the elements, they have difference in their atomic size due to their difference in atomic number. We talk about the reactivity of elements of group 1st, 2nd and 3rd. Reactivity of the elements of group 1st, 2nd and 3rd, and reactivity of the elements of group 5th, 6th and 7th the most. We talk about it. Now let's go towards the reactivity of elements of group 1st, 2nd and 3rd. In group 1st, 2nd and 3rd, let's talk about group 1st. We will give the example of group 1st. While moving from top to bottom, in groups, okay, in groups, while moving from top to bottom, first, what increases? Atomic number increases. Firstly, atomic number increases. When atomic number increases, then atomic size increases. When atomic size increases, obviously the number of electron increases. It is obvious for that the number of electron increases. Okay. And the main thing that you need to remember in group 1st, 2nd and 3rd, they are metals. They are electropositive in nature. Their electropositivity increases. Electropositivity also increases. Electropositivity means losing the electron. When they lose electrons they are negatively charged. When they lose electron, then they have positive charge more, one proton more, then they are positively charged, and they have higher tendency of losing the electron. Look here, just short demo over here. This is lithium. The atomic number of lithium is 3. 1, 2, 3. Lithium. Then sodium. The atomic number of sodium is 11. Then it will be 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 10, 1, 11. These two, okay? Look, the atomic number increases first while moving from top to bottom. 3, then 11. Okay? size increases. There are how many cells? 1, 2 cells. There are 1, 2, 3 cells. The force that binds the electron, the nuclear force that binds the electron of the cells orbits of the periodic table decreases while moving from top to bottom due to increase in size. When size increases, the force of nuclear attraction from the nucleus to the valence cell decreases. When force of attraction decreases, and when the force of attraction is decreased, higher will be the possibility of losing the electron. Okay, while moving from top to bottom, first the atomic number increases, second atomic size increases, third the number of electron increases, fourth electropositivity increases. Now this is over here. Electropositivity means, imagine yourself, this is smaller in size, the nuclear force attracting free electrons will be strong enough to hold this outermost electron. Look, this valence electron. But this in sodium, the force, the force is more, yes, but the increases. Obviously the force increases, but the increase in size and the number of electrons. Look how many electrons are there. More electrons are here, right? More electron means the force is divided, and very less amount of force this valence electron gains, by which there is high possibility of losing this valence electron. We can lose this valence electron easily, due to which it gains the reactivity faster. Reactivity of the elements increases faster because less nuclear force is applied in this valence electron and higher the possibility of losing the electron. Now let's talk about the reactivity of elements of group 5th, 6th and 7th. The elements of group 5th, 6th and 7th, they are electronegative in nature. It means they gain their stable electronic configuration by gaining the electronegativity. Electron is negatively charged, so it gains the negative charge and becomes one more negative charge, so it is electronegative in nature. While going from top to bottom, like that of group 1st, 2nd and 3rd, atomic number increases. First, atomic number increases. Secondly, the atomic size increases. Atomic size increases. Look, so this is fluorine and this is chlorine. Fluorine has atomic number 9 while chlorine has 17. The size of fluorine is less than the size of chlorine. It means the valence electron, look, in the valence cell gains more force of attraction from the nucleus. In chlorine, it gains less force of attraction from the nucleus. More the force of attraction, higher will be the possibility of gaining the electron. Less the force of attraction, lesser will be the possibility of gaining the electron. So, while moving from top to bottom, the reactivity of the elements in group 5th, 6th and 7th decreases. Look here. While moving from top to bottom, atomic number increases, atomic size increases, number of electron increases, obviously number of electron increases, electronegativity increases. Why electronegativity increases? Force of attraction decreases in the valence cell. In valence cell, the force of attraction decreases. When the force of attraction in valence cell decreases, when the force of attraction decreases in valence cell, the valence electron, then lesser will be the possibility of gaining the electron. Less will be the possibility of gaining the electron. If it gains the electron faster, then it is more reactive because they are electronegative in nature. They gain the electron and take part in chemical reaction and gain stable electronic configuration. So reactivity of the elements decreases while going from top to bottom in group 5th, 6th and 7th. In 1st, 2nd, 3rd, while moving from top to bottom, the reactivity increases. Same thing goes in 1st, 2nd, 3rd. Atomic number increases, size increases, electron increases, electropositivity increases in group 1st, 2nd, 3rd, electronegativity increases in 5th, 6th, 7th. Force of attraction decreases, yes, and in 1st, 2nd, 3rd, higher will be the possibility of losing the electron, so reactivity increases. in fifth, sixth, seventh, lesser will be the possibility of gaining the electron, so the reactivity decreases. Or we can even tell of group first, second and third, while moving from top to bottom, reactivity decreases. In fifth, sixth, seventh, while moving from bottom to top, the reactivity increases in group fifth, sixth and seventh. I think I told a mistake over there. While moving from bottom to top in group first, second and third, bottom to top, the reactivity decreases. And in fifth, sixth, seventh, while moving from bottom to top, the reactivity increases. This was for today. Stay connected with Maxim Education. I will be soon again in next video.